Hi, so I'm going to try in under 10 minutes to go through just some basics on logarithms. So here's what I hope to accomplish. We're going to go through a basic definition. We're going to talk about evaluating. I'm going to show you the three different properties used to expand or condense log expressions. And we're going to talk about a fourth property, the change of base property, that allows us to find approximate values for non-nice logarithms. Okay, so first off, the definition. And really, most books I see define it as an inverse operator for exponentials. And that's just the easiest way to see it, because exponentials are more familiar to us. So here, take a look at 2 to the 5th equals 32. And you can verify if you want. So in this part, we understand that 2 is the base, 5 is the exponent, and 32 is the result. Well, that has its own logarithmic version as well. You can see some of the examples we're going to work down here. And here's what it looks like for this 2 to the 5th equals 32. We write the word log for logarithm, and then it has a base. So the base that was over here is the base that's here. And we write it right after the word log, and it's a little subscript. So log base 2, that's what we say, log base 2. It's kind of a comma in there when you're saying it, of. Well, now the thing that we take the log of is the result from the exponential version. So it's log base 2 of 32, and then the answer is the exponent. So the answer, the result for a log equation, for a log evaluate question is, what power do I need to raise the base 2 in order to get that argument, to get the 32? Okay, so let's take a look at these. Looks like I have 6 examples. Maybe I can keep that top one on the screen too so we can kind of have a reference. So remember, as we go through these 6 examples, we're thinking, okay, what do we have to raise that base to get to the argument? Okay. So practice saying it. Log base 6 of 216. So 6 to what? And these are all nice. They're integers or rational numbers or something like that. So 6 to what number gets me to 216? So maybe even you write that someplace. So you're thinking off to the side here, 6 to what power gets me 216? Right, 3. Right? So log base 6 of 216 is 3, because 6 to the 3rd is 216. Okay? If we work down, log base 2 of 16. 2 to the what gets me 16. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 4th is 16, so that means this answer is 4. That's the power for the base to get me to 16. Okay, I'm going to have to speed it up or I'm never going to make it in 10 minutes. Log base 7 of 1. 7 to the what to get 1? Pause if you want to think about it. Otherwise, we all know that anything to the 0 power gives us 1. Okay, anything real and all of those, but for us, anything gives us, right, anything to the 0 gives us 1. Okay, a little more tricky. Log base 8 of 2. And you're thinking 3, right? Jumped into everybody's head because that's the relationship between 8 and 2 power rise. But remember, now it's my base of 8. And somehow I have to get from 8, so let's write this down, with an exponent to 2. So 8 cubed is not 2. But you're thinking, yeah, but 2 cubed is 8, so that means it's an inverse idea. So it's the cubed root of 8. That's 2. And then if we write cubed root as an exponent, remember that's a fractional exponent, so 8 to the 1/3 gives me 2. So that power is my answer, 1/3. 8 to the 1/3 is 2. One more tricky one here. Log base 5 of 1/25. So now I have to get that 5 into the bottom. And you're saying, 2, Angela, 2. Yes, I know it's 2. But it's going below. How do I get the 5 squared below the fraction bar? Exactly. Negative numbers do that for us. 5 to the negative 2, right? Scribble that in right here. 5 to the negative 2, 1 over 5 to the positive 2, which gives us that 1/25th. So again, our answers, our results are always what power do we need to apply to the base that gets the argument. Okay, log base W of W to the 12th. Yeah, okay, not very interesting. 12. W to the 12th gets me W to the 12th. Okay, so let's take a look at our three properties. So here they are. And I'm using just a generic base A on these. They could be anything. And typically they'll be numbers. So the first one, log base A of U times V. So if we're taking the logarithm of a product, we can split that apart into two different logs with the same base, and it's a sum. So a product of the arguments leads to the sum of two different logarithms. Log base A of U times V is log base A of U plus log base A of V. Okay. Log base A of U divided by V. Hey, guess what? It's very similar. Log base A of U minus log base A of V. Okay, so if we divide in the argument, it's a minus when we split it apart into two logs. Okay. And this last one, it's an exponent property, so this power can come down in front. Log base A of U to the B equals B times log base A of U. So one thing to keep in mind is that all three of these properties can work in both directions. So sometimes we'll work them this way, and typically that's when the instructions are expand. And the other way, right, we'll work them in this direction if the instructions are condense. Oh, pretend there's an N in there. Okay. So I have two examples, one of each. So the first one, use the log properties to rewrite as a single log expression. Okay, that's the long version of condense. Okay, so I need to condense this expression here. They all have the same base, so that's good. So the log base 3 of x plus 2 times log base 3 of y minus log base 3 of w. Okay, so here I'm working, right, I'm going to slide. I see one of these, I have the sum of two logs, but I'm going this direction, so I'm going to write a product of those two. But you might also notice that I've got a coefficient in front of one of mine, so I'm going to use this third property a little bit. And there's a minus sign in there someplace, so I'll use the second property as well. So here's how they all go. This 2 here, right, is going to come up and become the power of my y. Notice I'm writing that base in every time. Now these two are adding, so I can combine those as a product. Log base 3 of xy squared minus log base 3 of w. Okay. And now I have two logs that are subtracting, so I'm going to bring my answer over here just for space. So log base 3 in the numerator, xy squared, and then since I'm subtracting the y in my argument, it goes in the denominator. And I'll just sneak some parentheses in there to keep that argument all together. Oh, I'm not going to make it. It's going to be close to 10 minutes, though. Thanks for your patience. Okay, now this time we're going to expand. So this is going the other direction. Okay? The first thing we want to do is say, oh, what about that square root? I don't know. You didn't tell us that part. I kind of did a little bit back on the first page, right? If we have roots, if we have radicals, we can write those as powers. So the square root of that is the same thing as that argument raised to the 1/2 power, right? So now we can use that third property to bring the 1/2 down in front. Okay, here we go. Do you guys want to pause it and try it on your own? Okay, I'm going to keep going. Here we go. 1/2 log base 5 of 2x over 5y. Same thing as 1/2. I'm going to use some parentheses now because it might start getting ugly. Log base 5 of 2x minus log base 5 of 5y. Now inside here I've got another product in each of those that I'll have to deal with. Here we go. 1/2 log base 5 of 2 plus log base 5 of x minus, now it's minusing both of those, so I'm just going to assume you can take care of that, minus log base 5 of 5, another minus, it distributes log base 5 of y. Okay. So that could be one possible answer. If you wanted to get super brownie points from your instructor, you might say, hey, but I learned yesterday, you taught us so well that log base 5 of 5 is just a very convoluted way to write the number 1, so you could tidy that up, and I don't think I have enough room. But imagine all of that with this whole thing being replaced by the number 1. And that is it expanded. Okay, I told you I'd show you the change of base property, so let's take a look at that. So this lets us use our calculators to solve some of these exponent or these log questions if it's not something we just know. Okay. So my screen's a little dirty, but I think you'll be able to read off of it. So log base a of x equals the log base b. I'm going to change the base to something else. Log base a of x is the same thing as log base b of x divided by the log base b of a. Think, well, how does that help me? We've gone from 1 log to 2. Well, I know, but my calculator will do the heavy lifting for me as long as I choose b to be values that my calculator does. And it, just like yours, only does 2 bases. It'll do base 10. This is the LOG button you can find. And it will also do base E, and that's the LN button you can find. And it doesn't matter which one you choose, but you have to be doing the same one on the top and the bottom. Okay. So for instance, I have log base 2 of 12. 2 to what power gets me 12? Well, it's not anything nice, but right, we could probably ballpark it. 2 to the 3rd is 8, 2 to the 4th is 16, somewhere between 3 and 4. But I don't know what it is exactly. Okay. But my change of base property says it's the same thing. It's equivalent to log base 10 of 12, argument goes on top, divided by log base 10 of 2. Okay? And remember, when the base is 10, we don't typically write it. So I'm going to sneak my calculator in. I know it'll be tiny. So if I do log of 10 or 12 divided by log of 2, it's approximately 3.585. Okay? And you would get the same number if you did natural log of 12 divided by natural log of 2. I'll let you verify that on your own. Okay? Likewise on this one, now we'll do natural log. So natural log, the argument goes on top. Natural log, base goes on bottom. And then your calculator will give you that result. Be sure to close off the parentheses before you start your next log. 0.43, approximately, squiggle those. 0.43 is what my calculator told me, and hopefully yours told you the same thing. Okay, so one last thing before I let you go. There are some restrictions that I haven't told you about, and they are important. So when you're doing your logs, your base A has to be positive, greater than 0, and it can't be 1. Can't have a log base 1. And then the argument has to be positive. All right. Okay, 15 minutes. Shucks. Good job, guys.